Studying world chemistry, we're looking at Chatelier's principle. The Chatelier's principle was created by Henry Louis Chatelier, 1815 to 1936. There's a picture in Le Chatelier, and it says, an equilibrium reaction in a closed system is under stress will move in the direction to eliminate that stress. Now, what kind of stresses and how are they removed? The stress removed by shifting the equilibrium product constant. So the stresses are either change in temperature, change in concentration, change in pressure, use of a catalyst. Substance will increase the rate of reaction with, and catalyst is subsequent reaction without being consumed. All right, so temperature. What do we for temperature? Type of reaction when the energy is released or absorbed. It's either endothermic or exothermic. Again, endothermic is a reaction when energy is absorbed. Exothermic energy is released. If the energy is increased, it will shift to the other side from the energy. If energy decreased, it will shift to the side where energy is. So let's look at the reaction here. We have energy plus copper sulfate gives us sodium hydroxide plus sodium sulfate yielding sodium sulfate and copper 2 hydroxide. Okay, the reaction is endothermic because energy is a reactant. Okay, and if I increase the temperature here, okay, we're going to put more energy in. So E is a reactant. It's going to shift to the opposite side. So in this case, it's going to decrease the KQ and will shift. If it decreases, hit the same side. So in this case, it's going to shift towards the product. So understanding that if it increases, it'll shift the opposite side, decreases, shift where it's at. E is on the reactant side, it's going to shift the opposite side, it's going to shift towards the products. KQ will increase. So let's look at this one. In this case, the reaction is exothermic. Okay, temperature is decreased. E is a product. KQ will shift towards the products. Okay, now concentration acts like energy. Whatever side it's on, it's going to shift to the opposite side. So if I increase the concentration of Cl2, that's on the reactant side, it's going to shift towards the products. KQ will shift towards the products. The concentration of CO2, because CO2 is a product, it's going to shift to the opposite side, shift to the reactants. All right, if concentration of Cl2 decreases in the reaction, Cl2 is a product, decreases, shift to the side where it's at, it's going to shift to the products. All right, now, in order to do pressure, we look at gas law, look at Boyle's law. If pressure goes up, that means volume goes down. We're going to go side the least number of moles. If pressure goes down, volume goes up, we're going to side with the most number of moles. So look at this problem here. We have carbon dioxide. Carbon monoxide plus oxygen gives us carbon dioxide. Balancing it up, we have 2 carbon monoxides plus 1 oxygen. It equal gives it 2 carbon dioxides. I have 3 moles of gas here, 2 moles of gas over here. So if I increase the pressure, decrease volume, least moles, that means this reaction is going to shift towards the products. In contrast, if I decrease pressure, it's going to go side with the most moles. That means it's going to shift towards the reactants. All right, so catalyst. What's a catalyst? Catalyst is something that lowers the energy activation. And something increases the reaction without being consumed. It does that by lowering the energy of activation. What do we mean? Okay, here's a diagram of energy versus time for a reaction. We have our reactants, we have our products. Now, in order for the reaction to come, we have a specific amount of energy we have to overcome. That amount of energy is known as E sub A, the energy of activation. So what a catalyst does is it lowers the energy of activation, makes the reaction take place quicker. Okay? For a catalyst, the KQ is always no shift. It doesn't cause it to go to reactants or reactants. It stays exactly where it's at. It just gets there faster. All right? What I want you to do, we'll do this in class. I want you to go through and identify these and see if there's any problem. We'll do these in class. All right, and then copy these down. You'll do this with a partner. All right, any questions, let me know. Take care, be good.